Hello everyone, my name is Devinder Kaur and you all are welcome to my YouTube channel The Enlightened Room. Today in this video we will discuss about types of covalent bonding. So let's get started. Well, dear students, covalent bonding can be considered of three types. First one is single bond. Second one is double bond. And third one is triple bond. Now, in case of single bond, what happens that two atoms A or B would mutually share one electron. That means one electron from A and one electron from B. These two would mutually share these electrons, and when these electrons are shared, a bond is formed between them. Now this bond is single bond. The single line shows that this bond is single bond. Also single pair of electrons has been shared. That's why it is considered as single bond. Now the examples of it are chlorine, hydrogen. Okay, these two are examples of single bond or monovalent bond. Now why it is called monovalent bond, we will discuss about it, and we will also discuss about these examples. Okay, but first we will go through these types of bonding. Okay, now let us get to the point for double bond. In case of double bond, again let us assume that we have these two atoms, and now these two atoms are sharing two pairs of electrons. They are mutually sharing these two pairs of electrons, and these two pairs are now forming a bond. Since two pairs of electrons has been shared, the bond will be double bond and will be denoted as two lines. Okay, similarly in case of triple bond, three pairs of electrons has been shared, 1, 2 and 3, and three bonds are formed. Triple bonding has been formed and is denoted by three lines, and here is the triple bond. Okay, apart from this, tetrahedral bond is also present, and we will also discuss about it. Now first let us take the example of hydrogen and chlorine. Well, dear students, in case of hydrogen, you all are very well known that hydrogen has one proton and one electron, right? If it has one proton, that means it has atomic number of 1, and since it is electrically neutral, it has one electron. Okay, so I will write hydrogen like this, and it has one electron here. Okay, or I will write it inside here. Just keep it here. Okay, now to attain this stability or to attain the nearest noble gas configuration, hydrogen would try to complete its duplet. That means hydrogen would try that it would have one more electron. Okay, so in this attempt, hydrogen itself makes a bond with another hydrogen atom, and these two hydrogen atoms would share their single electron to do what? To make a covalent bond and would form a molecule H2. So here you can see, now I am writing this one electron here or denoting this one electron here. The reason why it is that, so that it would be easy for me to match them. Also the electrons should be facing each other. This is the rule. Okay, now this hydrogen would make bond with this hydrogen. Which bond? Covalent bond, because these two would be sharing this electron with each other. So how would they share this electron? Like this. Now a bond is formed between them, right? A bond is formed between them, and now you can write it as H or H single bond H. Okay, now you can either denote these dot as cross too. Okay, so this dot structure is known as electron dot structure. Okay, since you can see the hydrogen had the valency of 1, it had only one shell, which is its outermost shell, and only one electron is present there. Also, this outermost shell is the first shell for electron. Only 2 electrons can be present in it. If there is third electron, then we will have to make the another shell. This is the rule for the electronic configuration and arrangement of electrons in an atom. So it has only one electron in its outermost shell, and that electron shows its valency. So since hydrogen has valency 1, it is known as monovalent. Okay, also it forms the single bond. Alright, now let us take the example of chlorine. We have covered the example of hydrogen now. Now we will cover the example of chlorine. Now in case of chlorine, what is the atomic number of chlorine? It is 17. Also, now this is H, bond H. You can also write it as H2 molecule. Okay, that's why I wrote H2 here and single H here. Okay, now these two have formed bond. These two hydrogen have formed bond and made H2, and the bond is covalent bond. Okay, now in case of chlorine, let's get back to the case of chlorine. In case of chlorine, we have 17 atomic number, that means 17 electrons are present, and we will arrange them as 2, 8, 7. Now 2 is in the innermost shell, K shell. The next shell is L, and the next one is M. So the outermost shell is M shell, and in the M shell 7 electrons are present. So how I would denote these electrons on the symbol of chlorine? I would denote it as 1, 2, 3, 4, 5, 6 and 7. These electrons show how many electrons, these dots show how many electrons are present in the outermost shell. Okay, so it is 7 electrons. Now chlorine also wants to complete its octet or complete its outermost shell to attain the noble gas configuration or to attain the stability. So what will chlorine do? Chlorine will also try to make a bond with another atom. So why not make a bond with chlorine? So if chlorine wants to make a bond with another chlorine atom, if it will lose its electron to that chlorine, one chlorine atom would become iron and the other would become stable. So that is not possible, because all the atoms possess the same behavior. All the atoms of a certain element possess same behavior. So chlorine will neither lose nor gain the electron with its respective or the same atom. It will share its electrons. So I am taking another chlorine atom that has 7 electrons in its outermost shell, and these electrons would form bond with each other, as you can see it here. Now the bond will be formed as this. We can denote it with the help of this electron dot structure. Now this bond is formed. I can also show it as like this. Now again a single bond is formed, and I can write it as Cl2, the chlorine molecule. Okay, now this single bond is here, the example of single bond. Also, if you pay attention, the valency of chlorine is 1, because it only needed 1 electron to complete its octet, and it shared that electron with another chlorine atom. So the you can say valency of chlorine is 1. Since valency of chlorine is 1, it would form single bond and it is considered as monovalent. Chlorine is also considered as monovalent. Now let's take the example of double bond. Now for that I would take the example of oxygen, the most simplest one. Okay. Now what is the atomic number of oxygen? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, 8. Fluorine, neon. It is only 2 atoms away to get the noble gas configuration. So let us take a look how it makes double bond. So chlorine has atomic number of 8. The electronic configuration of oxygen is 2, 6. It only needs 2 electrons to complete its octet or to attain stability. So in this process, what oxygen will do, let me write the outermost configuration or the presence of outermost electrons in case of oxygen: 1, 2, 3, 4, 5, 6. Now the reason why I am repeating these ones in the opposite phase so that they are easier to form bond. Also it is a rule for the electron dot structure. Okay. Now this is one oxygen. It will also try to form bond with the another oxygen. Okay. So I am placing the another oxygen here. It also has 6 electrons in its outermost shell. So these electrons would form a bond with each other. Okay. Now oxygen would form double bond and would be considered as O2 molecule. Now one thing you need to pay attention is that what about these dots? Since this one is a shared pair of electron, this one is known as shared pair of electrons. Now why it is known as shared pair of electrons? Because it has shared the electrons with the other atom. That means electrons are being mutually shared. Then what about the other ones, the leftovers? Those leftovers are known as lone pair of electrons. Okay, the leftovers are known as lone pair of electrons. So it is clear to you, the electrons which are shared between 2 atoms or 2 or more atoms are known as shared pair of electrons, and the electrons which are left in the outermost shell which are not being shared with the other atom are known as lone pair of electrons. Okay, so you all are clear with the oxygen. Oxygen forms double bond. Now why does it form double bond? Because it has valency of 2. It only needs 2 electrons to attain this stability. So oxygen would share its 2 electrons with other oxygen atom and would form double bond. Okay. So oxygen is sharing 2 pairs of electrons, while chlorine and hydrogen were sharing one single pair of electron. It is sharing double pair of electron. So that's why we can say, due to its valency of 2, due to sharing of 2 electrons with the other atom and making double bond, oxygen is what? Divalent. Oxygen is divalent. Now let's move on to the triple bond. In case of triple bond, let us take a simple example. Okay. Yes, let's take nitrogen, N3. Now nitrogen forms triple bond. I have already told you, but how? What is the atomic number of nitrogen? 7. It is 1 less than oxygen. If oxygen needed 2 electrons to attain the stability, to attain the noble gas configuration, how many electrons does nitrogen need? According to its electronic configuration, it needs 3 electrons. So it is clear, 3 pairs of electrons would be shared. So we will write for nitrogen as, since 3 electrons are needed, what is the valency of nitrogen? 3. So we will share 3 electrons here, 1, 2, 3, and the other 2 will be left here. The another nitrogen is here, 1, 2, 3, and the leftovers are here. So these 3 electrons would form bond with each other. These 3 electrons are shared pair of electrons. So nitrogen would form triple bond here. Okay. How many shared pair of electrons are there? 3. This one, 1, 2, 3. How many lone pairs of electrons are there? These 2. The leftovers are lone pair of electron. Okay. Since we have made, until now we have only discussed about those atoms in which they only join with each other, with their respective themselves. That means hydrogen is making bond with hydrogen, chlorine is making bond with chlorine, oxygen is making bond with oxygen only, nitrogen is making bond with nitrogen only. So let us talk about some different examples. Let's take ammonia, NH3. Now how many electrons are needed by nitrogen to complete its octet? 3. Okay, so I would write 1, 2, 3 and the leftovers here. How many electrons does hydrogen need? 1. But if 3 electrons are present in ammonia, that means there would be, if 3 hydrogen are present, then every hydrogen would be making a single bond with nitrogen to make this formula. How? This is here hydrogen. Okay. Let us say for hydrogen it is cross, so that it is easy for us. Okay. Oh, sorry about this. 1 hydrogen is here and 1 hydrogen is here. So how would they form bond? This is my nitrogen. Okay, 1, 2 and 3. In this is how the bond will be formed between them. Okay, this is how the electron dot structure looks like. 3 hydrogen molecules or 3 hydrogen atoms are revolving or roaming around nitrogen. Nitrogen finds them and says, hi, wanna make a bond with me? So these hydrogen guys say, yeah, why not? So this is how they make bond. Okay, 1 electron from hydrogen and 1 electron from nitrogen here. 1 electron from hydrogen, 1 from nitrogen here. 1 from hydrogen, 1 from hydrogen here, and this one is lone pair of electrons, and this is how nitrogen would make the bond with other hydrogens, and this is how the formula NH3 forms. And what kind of bonding is here now? Think about it. What kind of bonding is here now? Trivalent bonding, because 3 covalent bonds are present here. It is triple bonding or trivalent bonding, whatever you want to say. Triple bonding is here. Okay, 3 covalent bonds are here. Let us take more example. Let us talk about HCl. What is HCl? Hydrochloric acid. Right? Now, if you pay attention, hydrogen has 1 electron. Chlorine also has 7 electrons in its valence shell, and the valency of chlorine is 1, valency of hydrogen is 1. They would try to make a bond with each other. Okay, so hydrogen, chlorine, the bond has been formed and it is HCl. So what kind of bond is this? Single covalent bond, because only 1 pair of electron has been shared and the leftovers are lone pair of electrons in case of chlorine. Okay, Now the examples we have discussed until now, all of them are non-carbon compounds or non-carbon molecules. Let us take one example of carbon molecule or carbon or you can say carbon bonding, okay, carbon compounds, whatever you wanna say, okay. So I am taking the example of carbon one. For that, let us take the simplest, okay, let us take the simplest one. It is CH4. What is the CH4? It is methane. Now according to carbon, what is the atomic number of carbon? It is 6. Electronic configuration is 2, 4. That means 4 electrons are present in its valence shell. And it needs 4 more electrons to complete its octet and attain this stability. So carbon cannot lose or gain this much amount of electrons. We have discussed about it in the previous video. So what carbon will do? Carbon would share 1 electron with all the hydrogens, as you can see here, okay, like this. So when the bond forms, it would look like this. This is carbon here, H, H, the bond has been formed, chemical reaction has occurred, and the molecule, a new molecule has been formed, which is CH4, and this is methane. Now what kind of bonding is here? There are 4 bonds. It is tetrahedral bonding. Now this, why it is known as tetrahedral? On this board it would be looking like a planar structure, but this structure, structure of this molecule is not planar, it is tetrahedral, okay. 4 bonds are present, and also the structure of the molecule would be formed as tetrahedral structure. You all would be clear about that structure, okay. You all would have studied it in mathematics, and it has a certain bond angle between carbon and hydrogen atoms. It has certain bond length, and it is fixed, okay. So we have until now discussed about types of covalent bonding, single bond, double bond, triple bond, and we have also discussed about covalent bonding formed by carbon, which shows a tetrahedral structure, and I hope it is clear to you all. One more thing that should be noted, that 2 atoms cannot mutually share more than 3 pairs of electrons, because the electron-electron repulsions between the 4 and more shared pairs would make the molecules unstable. That's why in case of nitrogen, it can form 3 pairs of electrons, but if we are talking about only 2 electrons, more than 3 pairs is unstable for that molecule. Talking about methane had formed bonds with 4 distinct hydrogens. So they are not 2 atoms, you can say there are 5 atoms present, okay. So that's why it is CH4, 4 atoms of hydrogen and 1 atom of carbon. That's how it has formed 4 pairs of 4, it has shared 4 pairs of electrons, okay. So this is up for today's video. I hope you found this video useful. If you found it useful, then do share it with your friends and your classmates or batchmates, and also subscribe to my channel if you haven't subscribed it yet. Thank you for watching.